Well everyone, the RTX 5090 is here and I wanted to start off this review a little bit differently, and that is to contextualize this video for a lot of people watching. We have only had this card for less than 3 days, and I wanted to thank the entire team here for just the titanic effort that it took to make this video possible. I'm the guy who's in front of the camera here. There's a whole team of people that have put in countless hours to make this possible. Anyways, in the short time that we've had this card, the results that we got with it led the content in a very different direction. And that's what I wanted to discuss here. I mean, even before today, we all knew the RTX 5090 would be the fastest GPU on the planet. The only question is by how much? Well, it turns out it might actually be too fast, even for the highest end system currently available. That was the first realization that we came to. I also wanted to address some burning questions like PCIe bandwidth scaling, since it'll matter for anybody who wants to use a riser cable in their build. And of course, concerns about the RTX 5090's overall power needs and temperatures. So let's start off with those, because what Nvidia claims here is a pretty eye-watering total graphics power of 575 watts, which also leads to a lot more heat to dissipate than a 450 watt RTX 4090. Meanwhile, the Founders Edition, it only takes up 2 slots, despite being the same length and width as the FE 4090. I mean, overall, this thing, from the way you're looking at it right now, might not look all that much smaller than the RTX 4090 Founders Edition. I mean, look, it's essentially the same length and the same width. But when you look at it this way, this card is only double slot, whereas the Founders Edition of the 4090 is triple slot. And for most people sporting massive cases, that isn't really going to factor into their buying decision. On the other hand, for people who have ITX systems like this one, the dual slot nature of the Founders Edition 5090 is a pretty big deal. It's also a lot easier to get power into, since its 16-pin power connector is installed vertically and slightly angled. I'm not entirely sure about this placement since it causes some really odd cable routing, but at least Nvidia's quad 8-pin adapter is hyper flexible. Either way, Nvidia recommends a 1000 watt power supply for systems running this card. Also, if your power supply does have one of those 16-pin PCIe power connectors, don't go out and automatically assume that it is compatible with the RTX 5090, because that connector needs to be rated for 600 watts at least, and not all of those are made equally. There are 450 watt versions and even lower on some power supplies. But look, we're talking about 575 watts TGP for this thing and 600 watt connectors. Does the RTX 5090 actually suck back that amount? Well, the answer to that is yes and no. Let's start with comparing it at 1440p to the RTX 4090, which used Nvidia's power modulation technology to dynamically adjust input current based on each game's requirements. On average, across 14 games we tested, it used about 325 watts. Now let's overlay the RTX 5090 onto this, and while it does require a hell of a lot more juice, it gets nowhere near to its rated 575 watts. Overall, that led to a continual power draw being around 396 watts, with some games like Baldur's Gate, CS2, Space Marine, Starfield, and Spider-Man needing in some cases much less than that. And yet those relatively tame numbers are completely turned on their heads when these GPUs are hit with a more demanding 4K raster workload. While the RTX 4090 sees moderate power consumption increases, well, the RTX 5090 chugs down much more. And remember, these are averaged over the run, so the peaks can be quite a lot more. Adding ray tracing to that equation finally sees the RTX 5090 getting close to 575 watts. And yeah, even the 4090 sees some pretty substantial power consumption increases here too. This thing can be really hungry when those RT cores get involved. Alright, so now we know that the RTX 5090 can be a lot less power hungry in certain situations, resolutions, and detail settings than some people might have assumed. At other points, it'll just chug back almost 575 watts. But we have to remember, that kind of high power consumption also leads to a massive amount of heat to deal with. And to tackle that, Nvidia's designed what they call a double flow-through cooler that uses a large vapor chamber and cantilevered heat pipes, which maximizes horizontal heatsink area, so they didn't need to build their fin stack vertically. That leads to its compact dual slot size, something that's pretty unique when you consider the ridiculously over-designed board partner cards. But does all of that design lead to better temperatures and acoustics. In order to find out, well, we took actually the worst case scenario that we've come across, and that is Cyberpunk at 1440p, 4K, and 4K with ray tracing. How does the RTX 5090 compete against the RTX 4090, that is a larger and heavier card? Well, at the moderate to high heat loads of 1440p, the RTX 5090 runs at about the same temperature while also being just a bit louder. Even when power needs are kicked up by a significant amount at 4K, the card keeps to roughly the same temperatures as a 4090, though there's definitely a correlation between a higher resolution and increased heat and noise. And finally, pushing things to the absolute max, while the smaller dual slot RTX 5090 did get hotter than the 4090, it wasn't by all that much despite having a massive size difference between the two cards. And yet there is a trade-off here. The 5090 did get louder, which I guess is understandable when you consider it's trying to dissipate so much more wattage than the 4090. Now during those tests, some of you might have seen something that sort of looked a little bit odd, and that's the fact that there was a couple of games at both resolutions that ended up producing a lot less heat and taking a lot less power on the RTX 5090 than anyone expected. Those, they raised some red flags for us. So we did a little bit more investigating into it. And the reason that was happening, well, it popped up right away. So let's set the stage here by looking at GPU utilization using the RTX 4090 paired up with our 9800 X3D. In any gaming PC, you want this utilization number to be as close as possible to 100%, like in most of the games here. Meanwhile, something lower than about, say, 95% is typically an indicator the graphics card is waiting around for the game engine, your CPU, or another system component to simply catch up, or there's some missing driver optimization somewhere. And when we overlay the RTX 5090 onto this, suddenly 6 of the 14 games seem to have a bottleneck that's preventing it from using all of its resources. So even at the absolute highest detailed settings, with the fastest gaming CPU available right now, Nvidia's new flagship is leaving performance on the table at 1440p. Meanwhile, at 4K, the RTX 4090 sees every game pretty much maxing out its processing capacity. And in the 5090's case, yes, there's a lot more sitting at that 97 to 99 number that we're looking for, but there's still some situations like Spider-Man, Rainbow Six, Hogwarts, and Baldur's Gate 3 where this card can't seem to flex its true potential, be it due to drivers, a CPU bottleneck, or some other outside factor. Move into ray trace scenarios with the highest possible settings, and you'd expect all the roadblocks we saw in rastered 1440p games to melt away, but that wasn't the case. Both Hogwarts and Spider-Man continue to see substantially lower GPU utilization than we normally expect. Then at 4K with RT on, we finally see Hogwarts heading towards a bottleneck-free situation while Spider-Man is still being limited. And I'll be honest with you here, it's really hard to nail down exactly why this is happening, but during our run, the CPU was pegged at almost 80%, and these numbers are something you'll absolutely need to take into account as we move into gameplay testing, because in some cases, the RTX 5090 is actually powerful enough to have its performance artificially capped. And speaking of testing, we wanted to do things a little bit differently here as well. And that is to focus on situations where this card would normally find itself in, right? Not just mounted horizontally like you would normally do in a traditional setup, but also mounted vertically like in that height Y60, or maybe in an ITX case like the Fractal Ridge. And that's important because neither of those run the GPU directly from the motherboard's PCIe slot, and instead use a PCIe Gen 4 riser cable. Meanwhile, there's also tons of perfectly good cases out there which run their risers at PCIe Gen 3 speeds. So we wanted to know, since the RTX 5090 is a Gen 5 card, how does performance scale across Gen 4 and Gen 3 interfaces? If there's a significant performance hit, this GPU could be simply dead on arrival for a lot of would-be buyers, because right now there isn't a single case shipping with a Gen 5 riser. Meanwhile, the few Gen 5 risers that are actually out there tend to cost a small fortune, and we hear through the grapevine some might have issues running at full speed. So the first thing I wanted to tackle here is, of course, just pure compatibility. Are these Gen 4 and Gen 3 risers compatible with the RTX 5000 series? Well, we ran into some problems there right from the get-go, because when we tried to use a certified Gen 4 riser on the RTX 4000 series, absolutely no problem. But using that same riser on the 5000 series with a PCIe Gen 5 CPU like the Ryzen 9000 series or Intel 200 series, well, there were some pretty big speed bumps. Basically, we ran into blue screens, game crashes, failures to post, you name it. Sometimes the systems ran well, sometimes they simply didn't. So what's going on here? Well, it turns out that the ASUS and Gigabyte motherboards we used have communication conflicts when there's a riser cable installed and their PCIe links are in the default out-of-box auto settings. The only way around this, at least right now, was to manually set them to either Gen 4 or Gen 3. Basically, whatever the riser was capable of. So I'll say this straight up. If you're using a riser of any kind and you want to buy a PCIe Gen 5 GPU, it doesn't matter if it's from AMD or NVIDIA or whatever Intel has coming down the pipeline, you are going to want to make this change in the BIOS, even if that means running off of integrated graphics temporarily. Because in some situations, your system might not even get into the BIOS if you have a PCIe Gen 5 card installed on a Gen 3 or a Gen 4 riser. So with that being said, let's go over how we tested and how the results are presented. The RTX 5090 in its native Gen 5 mode directly attached to the motherboard will be at the very top of all of our charts. That's followed by frame rates from the card running at Gen 4 and Gen 3 speeds to replicate what would happen in a situation where there's a riser or a PCIe adapter involved. We tested every game at the absolute highest settings at 1440p, which is on the left of all the charts, and 4K, which is on the right-hand side. Okay, let's start with Alan Wake 2, where there's a bit of a yin and yang situation with the RTX 5090 only seeing minimal impacts from the Gen 4 and Gen 3 risers at 1440p, while there's a bit more at 4K. Nonetheless, it's able to stay 30% or more ahead of the RTX 4090 and on a completely different planet as the RTX 3090 Ti, another card that was launched for about $2 grand. Black Myth Wukong is another game that sees the RTX 5090 getting substantially better performance than the RTX 4090. And in this case, the jump is as much, if not more, than the frame rate increase between the 3090 Ti and RTX 4090. Again though, we're seeing there's a minor performance penalty, specifically at 1440p when moving from PCIe Gen 5 to lower bandwidths. Meanwhile, Baldur's Gate is a game we've already established as having a CPU or game engine bottleneck at 1440p, so performance for all of these ultra high-end cards pretty much flatlines right across the board. Meanwhile, the only card that's slightly capped at 4K is the RTX 5090, and it still manages to beat the 4090 by a solid amount. CS2, on the other hand, is almost a write-off because look, any card here is able to push this game well past 400 frames per second at 1440p and 200 FPS at 4K. And yet, this is very important for competitive shooters like this. The RTX 5090's frame rate consistency is on a whole other level. In some cases, it can offer up to 50% better 1% lows, and for professional gamers, that could give them a distinct advantage. There are a couple of games on this list like Cyberpunk, where Nvidia has obviously fully optimized their RTX 4000 series cards, so at 1440p at least, they tend to look pretty favorable against the RTX 5090. But jump up to 4K, and that slim lead for the 5090 turns into a solid 45% advantage. It was obviously built for 4K gaming. Other games like Doom, well, they tell a different story. Since they're so well optimized to deliver high frame rates, that gap between Nvidia's two flagships becomes infinitesimal, especially at 1440p. 4K, on the other hand, well, it allows the 5090 to gain a little bit bigger lead, but I think this highlights that in general, there aren't many games out there that'll fully take advantage of this new card's horsepower, at least not yet, because some titles like this one end up having a processor bottleneck at 1440p with ultra details. Yes, even with a 9800X3D, and it's only when switching to 4K Ultra where the RTX 5090 is able to claw back a little bit of its lead of between 30 to 40%. Hogwarts, well, that's another game that's limited in some way or another, and I think we can firmly point a finger at driver optimizations here, because while the average frame rate is perfectly fine, the overall gameplay experience on the new Nvidia card is simply terrible. It's filled with micro stutters, which is why the 1% lows are just unbelievably low for a card of this caliber. Then again, this is an Unreal Engine game, guys, and there isn't a single GPU here that can deliver a completely smooth experience. By now, it should also be pretty obvious the RTX 5090's biggest gains seem to come in the latest titles, while slightly older ones like Horizon Forbidden West don't see nearly the same advantage, even at 4K. I mean, we're still looking at a good 20% increase versus the RTX 4090 and a doubling of the RTX 3090 Ti's numbers, but the delta is nowhere near what that previous generational uplift ever offered. Then again, even some newer but less graphically intensive titles like Black Ops 6 fall into that category too. And the question becomes, how much performance is enough for the games that you actually play? I should also mention that PCIe scaling is, in most of these titles, well within the margin of error, with all of the interfaces offering literally identical performance. Like, think about it. Would you be buying a $2,000 GPU to play something like Rainbow Six? Probably not, but what you're likely going to be looking for is a graphics card of this caliber to deliver class-leading performance in easier to run games like this one, while also having a ton of power left in the tank for more demanding titles. And that's exactly what the RTX 5090 seems to offer. And I also want to sort of bring us back to the bottlenecking conversation, because based on our analysis earlier in this video, that's exactly what's happening with Spider-Man Remastered at both resolutions. So it really makes you wonder, just how good would this card really be if it wasn't being somehow artificially held back? Even a game like Starfield falls into this category, where performance is being capped even on the RTX 4090 at 1440p, which causes all of that money that you just spent on a flagship GPU to essentially go to nothing. And here we are rounding out the Raster performance on a pretty high note for the RTX 5090, where it manages to solidly beat the 4090 at both resolutions, but again, 4K stands out. While the gap is just over 20% at 1440p, switching to UHD pushes that to almost 40%. Moving on to ray tracing, and the RTX 5090 provides a pretty big performance jump over the RTX 4090 in Alan Wake at both 1440p and 4K, a bit over 30% in both situations. But I'm not sure about you guys, I was sort of hoping for a bit more than this, especially in a title that's been sponsored so heavily by Nvidia. Meanwhile, Avatar in its unobtainium setting shows the delta between the 5090 and 4090 to be even less than it was in Alan Wake 2. The new card is certainly better, but if you were thinking this gap would start to increase in ray tracing scenarios, well, I've got news for you. That's just not happening. Because in some titles like Black Myth Wukong, the RTX 5090 can show some flashes of absolute brilliance, some insane performance at 1440p, but then it goes back to the usual 20 to 30% at other points, especially when 4K is factored into the equation. Overall though, this level of performance in ray trace scenarios is impressive, especially at the resolutions we're using, and the fact that there's no upscaling or frame generation applied. I mean, if you paid that $2,000 for an RTX 3090 Ti about 3 years ago and care about RT, well, the RTX 5090 represents a relatively huge upgrade. On the other hand, its performance relative to the RTX 4090 is situationally dependent, because for every Black Myth Wukong, there's a Doom Eternal. Basically, titles that see very little in the way of performance uplifts, even at 4K. And just like we saw in raster rendering scenarios, there's Hogwarts, which just doesn't seem to play nicely with Nvidia's newest GPU. You can get a good average frame rate boost at 4K, but the overall gameplay experience is just terrible. Again though, this is the only outlier in this whole review. And finally, there's Spider-Man Remastered, a game we've proven to have a highly problematic engine in both raster and RT in our GPU utilization testing. These issues actually trickle down into our PCIe bandwidth testing too. There's obviously just so much being left on the table here. And I think that point leads me right into where the RTX 5090 narrative is right now. This is a story about unrealized potential, because even with today's most powerful gaming CPU, the 9800X3D, this thing, in a lot of situations, is still bottlenecked at the highest settings at 1440p, and even in some scenarios at 4K. And that leads to an overall situation that looks something like this. At 1440p, the RTX 5090 really doesn't offer much in the way of tangible benefits over the RTX 4090, mostly because its performance is actually being capped in quite a few games. At 4K though, well, I've said this once and I'll say it again. This card is built for 4K gaming. period. And that's because it's where the 5090 avoids a lot of those bottlenecks and sees its biggest wins. On a more positive note, let's talk about that PCIe scaling that we've seen throughout this video. People using Gen 4 risers have absolutely nothing to worry about, since all things considered, they offer almost identical performance as a native Gen 5 interface. Gen 3, well, there's a bit more of a drop-off, but it's nothing to be overly concerned about. Ray tracing performance, well, disappointing is the one word that comes to mind. This is one area where NVIDIA should have and needed to improve the most, but we ended up with a lack of consistency. Some games saw the 5090 dominate, others had it flatlining. So in the end, it barely managed to outpace the 4090 by 20% at 4K. And look, I know a lot of people were hoping to see the same massive generational uplifts now as they did when the 4090 was launched, but unfortunately that just didn't happen. One of the main reasons behind that is the RTX 4000 series was highlighted by a change in the manufacturing process and all the benefits that came along with it. This generation, however, the RTX 5000 series is on the same manufacturing process as a 4000 series. And I'd actually argue that what NVIDIA accomplished here with the RTX 5090, while remaining on that same node, well, it's actually pretty impressive. Unfortunately though, as we saw in our testing, there's a corresponding heat and power increase right alongside the performance boosts. But what NVIDIA seems to be doing here is laying the foundation for the future of AI-powered graphics. The RTX 5000 series is just the first big, meaningful step towards realizing that. Much like the RTX 2000 series was the first step towards GPUs focused on ray tracing. And that leads to the RTX 5090 becoming a $2,000 GPU that's based more on NVIDIA's promises of what's to come than it is on performance uplifts in today's games. And for a lot of people, that will cause a huge problem. RTX 3090 Ti buyers who bought their cards, say 3 years ago for $2,000, you guys are gonna have a massive performance uplift. But right now, for a lot of people, this card, we're just going to have to see what happens with it and the promised features in the future. And that actually leads to a lot more testing that's needed on our part. This is not the last time you see the RTX 5090 on this channel. There is a lot of testing yet to come. It's just gonna have to wait until we get a little bit of sleep. So anyways, I'm Mike with Hardware Canucks, and I will see you in the next one. Have a great day, or in this case, have a great night, guys. Take care.